Hey, it's Chris McCord, and I wanted to show you a quick sneak peek of the upcoming Phoenix Presence features. So to do that, we're just going to create a quick application that shows a list of users that are currently online. So to do that, we can use the Mix Phoenix New Generator to generate a new Phoenix app. We'll call it Demo, and we're not using a database, so we'll pass no ecto. And we can go into the new application directory. And before we get started, we want to run the Mix Phoenix Gen Presence generator. This is going to add the presence supervisor that's going to give us the presence features in our application. Okay, so that added a web channels presence file, and we wanted to just follow the instructions and add the new supervisor to our application supervision tree. So that way everything gets started up for us. So I can do that in my application supervision file. I can just add the demo presence module, and that's going to be the thing that implements the Phoenix Tracker functionality that's going to give us the cluster membership, CRDT replication, everything that's happening internally. You just need to make sure you start it and it's going to be supervised for you. So we'll save that. And now we can start up our server and just make sure everything's running. Okay, we should be up and running now. Welcome to Phoenix. Awesome, it works. Okay, so our application is going to be really basic. We just want to show a list of users. So let's just update the main page template. And we can delete most of this, and let's just show maybe the current node. That way when we go multi-node, we'll see what users online. Okay, so that's the current node. So now we can add a UL here and give it the ID user list, and that'll hold our list of users. So we'll save that. Should be empty. And now we can go about implementing the real-time presence features. So to do that, we're going to need a channel. So if we go back into our application, we can create a room channel, which is going to say, a chat room is typically going to have a list of users, and we'll create a demo room channel. That's going to use demo web channel. We're also going to alias our new presence module so we can use it. And when someone joins this, they're only going to join the lobby for now. We can say that anyone can join the lobby. And all we need to do in this case is say, after we join, we want to send ourselves a message to process something as soon as we've joined. And otherwise, we're going to let anyone join this lobby. And then after we join, we can handle that in handle info. We're going to get an after join message, and we want to do a little bit of work here. One thing we're going to do is we want to grab like the user's ID and username from the socket. And for now, we're just going to say that the user's ID maybe can be their username to keep things simple. And to do that, we can use a new feature with our presence module that was generated called presence.track. So we can track this socket. So track my active socket connection, and I'm going to say it's going to be tracking the user's ID. So the socket's going to have some socket assigns user ID. And then we can give a map of metadata also to include information about this user's presence. So if you imagine if a user could have multiple presences, they can have multiple browser tabs open, but they can also be online from multiple devices. So you might have the user's device type that they connected with. So you might embed, maybe they connected from a browser or iOS. This could be any kind of ephemeral state, or maybe the time that they came online at. So in this case, it's just an example. I might append the OS timestamp just to show you how this works. Any kind of ephemeral state about the user. And after I say, okay, track my presence, I'm going to receive different events about users coming and going. And then I can also push down the current active user list. So I can push onto the socket, we'll call it presence state, and it's going to be a list of presences. So I can say presence.list. So give me all the users on this socket's topic, push that down to the client, and then we'll continue. So really, this is all the server code that's required to wire up real-time events across the cluster. So now that the server's done, we need to go, or now that the channel's done, we need to go into our user socket now and make sure this is wired up properly. So we just need to map rooms lobby to the room channel, and then we want to make sure we have a user ID for this socket. So we'll say anytime you connect, we expect you to pass up a user ID, and we'll just assign that to the socket. Alright, so that's it for the server. So now we can go into our application JavaScript. And we want to do a couple things here. We need to import sockets and presence from Phoenix. So we have a new presence object in the Phoenix JavaScript client. And this is going to give us almost like a CRDT on the client to sync state with the server. So first we want to create a new socket. And by default, that's going to be at /socket. And then we want to pass some params of our user ID. So we want to pass that user ID up to the server. And we're going to say we just expect for now a window user ID to exist. And we'll wire that up in a moment. And then we can connect. And after we've connected, we want to wire up a couple variables. So in this case, we need a handle to that DOM element of our user list. And we're going to need a room channel. So we can say room equals socket.channel. The topic is going to be the lobby. And we're not going to pass any params. And then we're also going to need a map or an object of presences. It's going to start as an empty object. And now we just need to handle a couple events to get this rolling. So first thing we need to do is we'll receive a presence state event that we wired up after you join. So we know that we're going to receive presence state. We get some initial state, and this is going to be fired anytime you join for the first time, or if you have disconnects. It's a way for you to get caught up on users that have come and left since you've been disconnected. And that's what the presence sync state function's for. It's going to resolve any kind of conflicts in between disconnects or your first connection. So we want to sync our presences, or our presences map with that full state. And then after we do that, we'll want to render our presences, and we'll write that function in a moment. And then the other event that we need to handle is a special event named presence diff. This is going to be a diff of users coming and going. So as data is replicated across a cluster, it's going to happen on some short interval, but you might have, multiple users, dozens coming and going, and you're going to get that event all that data in a single event. So we're going to get a diff of joins and leaves, and then we can handle that in one place here. And we provide a nice sync diff helper for you as well. This is going to say sync the diffs with my current presences state, and it's going to allow you to fire a callback here to see if a user has logged off from all the devices, or maybe they've joined from an additional device but they're already logged on. But by default, it's just going to sync that state for you. And then we want to render all of our new state whenever that happens. And the last thing we need to do is just join the channel. Okay, so we're just about done. We just need to write that render function. And we're just going to keep it simple. Render is going to take some presences, and we want to append this, or just re-render our user list inner HTML. So to do that, we have a presence list function, and the list is going to take your state, and then you give it some kind of callback as a way to how do you want to list the presences. Because since a user can be logged on from multiple devices and multiple tabs, you need to figure out which metadata do I want to pick. Is it from the user's most recently joined device, or is there some priority? You have to write a function to choose that. So we'll write that in a moment, but anytime we get a list, it's going to aggregate the users. We want to map over that, and we're going to get a user, and then we just want to return a string here. It's just going to be a list element, and then we want to have the user's name and maybe the number of devices or tabs they have open. We'll say user.count. It's the number of presences they have. And then after we've mapped over that, we just want to join that into a final string. And now we need to write that list by function. And list by is going to get the ID, so the key that you registered to track the presence on, and then a special metas key for the metadata for all this user ID's presences. So it's going to be a list, and the most recently joined presence is going to be the first element, and then we can just say the rest of the list is going to be any other tabs or devices that the user is joined on. We can destructure assign that. And since we didn't have a username, we're just going to say the name of that presence is just going to be the ID for now. And then we also want to be able to say how many presences this user has. So we're going to say the append a count key to that, and it's just going to be the rest.length plus 1, so how many presences they have, and then we can just return the first one. So the most recently joined presence gets priority, and anytime presence list gets called, it's going to use that list by function to figure out which presence to choose for each user. And this should be it to show a list of users coming and going. So let's go ahead and see if this works. And it looks like we had a JavaScript error. So let's see what it's complaining about. Add equals there, and we're good to go. Let's go back here. And we need to fix a variable reference. And we also need to wire up our user ID, because the window user ID here is going to be undefined. So what we can do in our application layout, since we don't really have any users in this system, we'll just append a quick script tag. And we'll just say that the window user ID is just going to be equal to the username param. So anytime there's a param query string with a name, we'll go ahead and make that the user ID for now, just so we can have something to show. Okay, so I'm going to pass my name now in the URL as Chris, and there I am. Cool, so I'm listed as online here, and it's showing 1 to signify the amount of presences I have. So now let's get a couple browser tabs open. And there I am. So now I'm online in 2 different locations, so that's pretty cool. So what about if I go ahead and open a third tab and maybe name it Chris2. So now Chris2 popped up over here. Chris2 is on both pages. Now if I close that tab, we should see it disappear from both screens. Boom, gone. Likewise, if I have 3 Chris's online, I'm going to close one, and we should see that number drop to 2 in both cases, and so on. So this is pretty cool. You didn't have to really worry about any of this, but this is only for a single node. So now let's see what happens if we can run this with distributed Elixir and see how easy it is to have this data replicated on the cluster. So to do that, I'm just going to wire up a couple quick rules here to connect our nodes together. So I have a blog post on that on Dockyard that takes you through that pretty easily. So let's check that out. Alright, so if we just make a sysconfig file here, we can wire up the nodes that we want clustered together. So I'm just going to copy this and run it in sysconfig here. So I'm going to say pb paste into sys.config. So now if I open that, we've got our sysconfig here, and I'm just going to have a couple nodes named node 1 and node 2. And they can wait a second to sync timeout. And then the other thing I can do is when I connect to run a Phoenix server, I can just tell it to load that configuration. And we want to add a period at the end of that. And then the only other thing I want to be able to do is be able to dynamically assign different ports. So in my dev EXS, I want to make sure that the port is going to be the system port from the environment or 4000. So that way just let me easily assign the ports. So one thing we want to do is open up our presence module, and we want to make sure, just temporarily, I want to set the log level to debug so we can see what's going on internally in the tracker as data is replicated. And now we can start up a couple nodes using the sysconfig that we had. So we can go ahead and just copy our command here, and we can pass a port. So we want this to be port 4001 using that configuration. We'll name it node 1. Oops. In the right directory here. Okay, we're up and running. So over here we want to run port 4002. We'll name this node 2. Go into the right directory again. Okay, cool. And you can see almost immediately it said that node 1 saw a replica up from node 2. So it detected that a node came online and joined the cluster. And now we can see node 2 detected a replica up from node 1. So now these nodes are aware of each other, and they're going to replicate that presence information back and forth automatically for you. So let's go see this in action. So if I go back to my browser tab, we have two tabs up and running. And port 4001 now is going to be node 1. And I'm going to just say this is Chris in 1. And then port 4002 is going to be node 2. So these are running on my one laptop, but they could be on totally separate computers. And we can see almost immediately Chris node 2 was just replicated over to node 1, almost faster than we could have noticed. So let's see it in action here if we open up a second tab. So on node 2, I'm going to open up a new tab and say this is going to be Bob. And we should see Bob, since Safari prefetched the information or did a preview of the page, it actually registered already. But that information was replicated over, and it's easier to see when I close a presence. So I'm going to close Bob's tab. We should see Bob immediately disappear from node 2 since it's local. And then as that diff of information is replicated across a cluster, Bob 1 should disappear probably in about a second or two. So here we go. Gone from the right, gone from the left. So we're replicating information across automatically. And the neat thing is this self-heals. So let's see how we can kind of mess this up a little bit as far as the nodes are concerned. So we have node 1 and node 2 running. So what happens if they have a net split? So there's some network interrupt. I'm going to simulate a network interrupt between these two nodes by doing a node disconnect. So we're going to say I'm going to disconnect from node 1. But in order to do that, I need to be running IEX. So let me go back and make sure I have both these nodes running under IEX. At least one node. Okay, so you can see that we had some down detection going, but I'll refresh both browsers. So we're back up and running. But now I can do a node disconnect. And I'm going to disconnect from node 1. Alright, so these nodes, I'm going to simulate some kind of network interrupt or a net split. So they're no longer able to talk to each other. And what happens if we have information changing? So let's say node 1 is going to have a new user join named Brian. And we can say node 2 is going to have a new user join. We'll name this user Max. Okay, so we've missed data here. So what happens when these recover? There's no central database, but they'll notice that they're behind and they'll catch each other up. So I'm going to clear the scroll back here. I'm going to reconnect these nodes and let's see what happens. There it goes. So the nodes detected that, okay, this replica came back online and its vector clocks were behind, so they are catching each other up. So here you can see they both requested transfer information back and forth, and they caught each other up. So if we go back to our browsers, we can see that automatically Brian and Max now are replicated and repaired on node 1, and node 2 also got the second window of Brian here. So that's pretty cool, right? You didn't have to do anything. They self-heal, and we even handle nodes going away permanently. So what a lot of systems do that you rely on the database or shoving data into Redis is if a node goes down, data is orphaned forever. So let's say that if node 2 goes offline, we should see node 2's Max and Chris and 2 disappear from node 1. They should not be orphaned. So I'm going to kill node 2 here. Gone. And now as soon as this is detected by node 1, these users are going to drop offline from node 2. And there they go. So those users were detected as down, or that replica was detected as down, and all those users were cleared automatically by Phoenix Presence. So we're really handling presence in a really robust way. It self-heals. There's no single source of truth. So everything is going to be super performant and super resistant to failure. So that's the lowdown on Phoenix Presence. We're hopefully nearing a release in the near future, but go ahead and check the source code out. It's available on Phoenix Master today, and let me know what you think. Thanks a lot.